everybody! Today Professor Ybella, will be discussing about the periodic table of elements. So the periodic table is an arrangement of the chemical elements structured by their atomic number, electron configuration, and recurring chemical properties. In the basic form, elements are presented in the order of increasing atomic number in the reading sequence left to right. The vertical columns on the periodic table are called groups or families because of their similar chemical behavior. All members of a family of elements have the same number of valence electrons and similar chemical properties. Always remember that rows is the periods and columns is the groups. Now that we know what a table is, what are elements? An element is a pure substance consisting of only atoms that have the same number of protons in their nuclei. Unlike chemical compounds, chemical elements cannot be broken down into simpler substances by any chemical reaction. The table may be confusing at first, so many letters and numbers, but there are some things that are noted to make the reader understand more about an element. So how are elements denoted? We'll be using hydrogen for this. The atomic number of an element is equal to the number of protons in an atom. It defines the element, and in this case it is number 1. The 1 or 2 letters refer to the nuclear symbol, and in this case it is letter H. It also has an atomic weight. For this case, it is 1.008. Metals, metalloids, and nonmetals are the 3 main parts of the periodic table. There are over 100 elements in the periodic table. Metals can be found on the left, metalloids in the middle, and nonmetals to the right. Most elements in the periodic table are metals. Metals are good conductors of heat and electricity, ductile and malleable, shiny, and they lose electrons when they react. Some examples are aluminum, silver, copper, gold, lead, and tin. Non-metals are dull, poor conductors of heat and electricity, high ionization levels, brittle, not ductile, and malleable. Non-metals include hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur, and selenium. Metalloids are brittle, shiny metallic elements that exhibit semiconductive properties. Unlike metals, they are not malleable nor ductile. Examples are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Now that we know all about the periodic table of elements, why is this useful to all scientists? The table is useful for modern students and scientists because it helps predict the types of chemical reactions that a particular element is likely to participate in. The table tells each element's atomic number and usually its atomic weight. The typical charge of an element is indicated by its group. Now that we already discussed about the periodic table of elements, let's move on to our next topic, which is compounds. So what are compounds? In science, a compound is a substance that results from a combination of 2 or more different elements. There are several compounds that we all use in our daily life which have become an essential part of our growth and survival. We encounter these compounds in our daily life, in the food we eat, in the water that we drink, and the air that we breathe. We have H2O, which is water, NaCl, which is sodium chloride that we find in our table salt, C12H22, NO11, carbon, hydrogen, and oxygen, which we find in our sugar, RCOO, where R is a long chain of carbon atoms ranging from 16 to 18 in number, and lastly, NaF, sodium fluoride, which we find in our toothpaste. Now that we discussed about compounds, why is it useful to us? Isn't this only for science? Why do we need to learn about this? We need to learn about this because we see these compounds in our everyday lives. This isn't only informative to us students, but also to everyone who uses them. So that was Professor Ybella's lecture about the periodic table and the compounds. So I hope you enjoyed my video, and I hope that you'll apply this knowledge into real life situations. Goodbye everyone, and thank you for listening.